In this video, I'm going to expand upon molecular orbitals, which I started talking about in my last video. I'm going to talk about a concept called hybridization. What this is about is that, if you recall, in my last video, I discussed sigma and pi bonds, which are the bonds that form when atomic orbitals overlap to form molecular orbitals. But what do we call those actual orbitals that form when you get that overlap to form the sigma and pi bonds? So, to make this kind of simple for right now, I'm just going to talk about how we figure out what type of orbital is going to form, and it's actually relatively simple. So it's based on the amount of electron domains. If you recall, I'll just kind of review that a bit. Electron domains, so it's based on the electron domain geometry. An electron domain, if we have, let's say, a central atom here. Remember, a sigma bond, or a single bond, is one electron domain. A double bond is still just one electron domain. A triple bond is still just one electron domain. And a lone pair is also an electron domain, right? So, so I'm going to set up a little table here. Electron domains. So the first column is going to be just the number of electron domains. Then the second one will be the electron domain geometry. And the last one is going to be the hybridization. And that is, what that means is basically, that is the hybrid orbital that forms around the central atom. So for one thing to keep in mind, whenever we're talking about hybridization, we're always going to be talking about the central atom, because we could be talking about hybridization for any atom that has at least two domains. So, if you recall back in my last video, I was showing you how to find the number of sigma and pi bonds. If in a molecule, a bigger molecule like that has more than one atom with multiple domains, you would have to specify, or the question potentially would have to specify what atom it's talking about when asking for hybridization, because you could actually look for the hybridization for each one individually. And actually at the end of this video we'll do that. So if you have two electron domains, your electron domain geometry is linear. And the way you want to think about this is however many domains, you're going to start with an s orbital. Now there's only one s orbital, so you'll get contribution from a p orbital, and that's contribution from 2 orbitals, and that's it. So this is not exactly how it works, but just this is a way you can try to remember what the hybridization is. So that hybridization is sp. Now, if you have 3 electron domains, your electron domain geometry is trigonal planar. So now we can go S. Now we need 2 more domains to consider. So we need 2 p orbitals. So we say sp2, and we put the 2 as effectively an exponent there. So that's sp2 hybridized. If we have 4 electron domains, our electron domain geometry is tetrahedral. So now we have sp3. Keep going. 5 electron domains. We have an electron domain geometry of trigonal bipyramidal. Ran out of room a little bit there, but you get the picture. So we can keep going with sp, but here's the thing: there are only 3 orbitals in a p subshell, right? So we can't go sp4 because there is no 4th p orbital to contribute to the hybridization. So you have to think about what orbital would come after a p. So now we get into the d orbitals. So we still have sp3, but that's only 4 orbitals, so we still need 1 more. So we give it 1 d orbital. And the last one you'll need to worry about for this class, if we have 6 domains, it's octahedral. we have sp3. Now we need contribution from 2 more still, so we go D2. So let's look at an example and actually use the same molecule that I used in the last video. So in the last video, I gave you this, and the oxygen would actually have 2 lone pairs. So remember, any atom that has at least 2 domains, we can look at for the hybridization. So in that case, we'll have this. It'll be the oxygen and each of the carbons. Right? So this oxygen has 1, 2, 3 domains. So that's sp2 hybridized. This carbon has 1, 2, 3 domains. It's also sp2. And actually, as I looked, 1, 2, 3 domains for this carbon. So that's sp2. And this carbon again, 1, 2, 3. So that's also sp2. But let's say, for instance, we had something like this. So this carbon has 1, 2, 3 domains. So this carbon is sp2. This one is also sp2. 3 bonds. This carbon has 1, 2, 3, 4 domains. So that carbon would be sp3. This carbon has just 1, 2, because that's a triple bond right there. So that would just be sp. And the nitrogen would also be sp. And that is how you can determine the hybridization for molecular orbitals.